Welcome to our deep dive into Kotlin Coroutines, focusing on the powerful withContext function. If you've ever wondered how to efficiently switch execution contexts in your Kotlin code without launching new coroutines, you're in the right place. Today, we'll explore what withContext is, why it's essential for modern Android and backend development, and how it can help you write cleaner, more efficient code. Whether you're a beginner or an experienced developer, understanding withContext will elevate your coroutine skills and help you manage background tasks with ease. WithContext is a suspending function in Kotlin coroutines that allows you to switch the coroutine's context, such as moving from the main thread to a background thread, while suspending the current coroutine. This means you can run a block of code in a specified context and get the result back, all without creating a new coroutine. It's a core tool for managing threading and concurrency in Kotlin, making your code both efficient and readable. Let's see how withContext fits into the coroutine ecosystem. When you call withContext, the current coroutine suspends its execution and switches to the specified context, such as dispatchers, I/O for I/O operations. The block of code you provide runs in this new context, and once it finishes, the coroutine resumes in its original context. This process is seamless and doesn't block the thread, making it highly efficient. You can use withContext for tasks like network requests or database operations, ensuring your main thread stays responsive. Unlike coroutine builders such as launch or async, withContext does not create a new coroutine. Instead, it reuses the current one, simply changing the execution context for the duration of the block. This means less overhead and simpler code, as you don't need to manage additional coroutine lifecycles. It's perfect for sequential tasks where you need to switch contexts temporarily and get the result immediately. Here's a simple example of using withContext. Suppose you want to perform a long-running task on a background thread. You can write val result equals withContext dispatchers, I/O, perform task result. After the block finishes, execution returns to the original context. This pattern is common for tasks like reading from a database or making network calls, keeping your UI thread free from heavy work. withContext stands out for its ability to switch contexts efficiently, suspend the current coroutine, and ensure that execution resumes in the original context. It's especially useful for separating I/O operations from UI updates, making your code more organized and less error-prone. By using withContext, you can keep your main thread responsive and delegate heavy work to appropriate thread pools. Imagine you need to fetch data from the network. You can use withContext dispatchers, I/O to perform the network call, and once it completes, your coroutine resumes on the main thread. This approach ensures that your UI remains smooth and responsive, while heavy tasks run in the background. It's a clean and effective way to manage threading in Kotlin. One of the biggest advantages of withContext is that it suspends the coroutine without blocking the thread. This means your application can handle many tasks concurrently without running into performance bottlenecks. The suspension is handled efficiently, allowing your app to scale and remain responsive even under heavy load. Under the hood, withContext uses advanced coroutine mechanisms to switch contexts. It checks if the new context is different from the current one, ensures the new context is active, and then either runs the block directly or dispatches it to a new thread pool. This internal logic is optimized for performance, minimizing overhead and ensuring that context switches are as fast as possible. Function signature for withContext is public suspend fun t with context coroutine context block, suspend coroutine scope. The context parameter specifies the new coroutine context, such as a dispatcher, while the block is the suspending lambda to execute. The result of type T is returned after the block finishes, making withContext ideal for sequential tasks where you need the result immediately. withContext enforces a contract that ensures the block you provide is called exactly once. This is important for optimization and guarantees that side effects occur only once. The contract helps the compiler with inlining and other optimizations, making your coroutine code both safe and efficient. The core of withContext implementation uses a low-level function called suspend coroutine unintercepted or return. This suspends the current coroutine and manages its continuation, allowing it to resume after the block finishes. This mechanism is what makes withContext so efficient and powerful for context switching. withContext retrieves both the old and new context before switching. The old context represents the current coroutine's context, while new context combines the old context with the new one you specify. This allows for flexible context management, such as adding thread local variables or switching dispatchers as needed. Before executing the block, withContext checks if the new context is still active using ensure active. If the context has been canceled, a cancellation exception is thrown. This safety check prevents running code in a canceled coroutine, maintaining the integrity of your application's execution flow. The new context is exactly the same as the old one. withContext takes a fast path and runs the block without any additional overhead. This means no thread switching or extra coroutine creation, making execution as efficient as possible. It's a smart optimization for cases where context switching isn't actually needed. The dispatcher hasn't changed, but other context elements have. withContext uses undispatched coroutine to run the block in the same thread. The function with coroutine context temporarily updates the thread's context, then reverts back after the block finishes. This ensures minimal disruption and efficient execution. When the dispatcher changes, withContext takes the slow path. It creates a dispatch coroutine and dispatches the block to a new thread pool. The block is started in a cancelable way, and the coroutine suspends until the result is available. This approach is necessary for tasks that require a different thread, such as heavy computations or I/O operations. Once the block inside withContext completes, the result is returned and the coroutine resumes from where it was suspended. This makes withContext ideal for sequential workflows where you need to wait for a result before proceeding. It keeps your code straightforward and easy to follow. Summarize: withContext first checks if a context switch is needed, ensures the new context is active, and then chooses the optimal execution path. Fast path for identical contexts, another fast path for same dispatcher, or slow path for a new dispatcher. After the block completes, it returns the result and resumes the coroutine. This design keeps your code efficient and robust. Dispatchers are a key part of withContext. They define which thread or thread pool your coroutine runs on. For example, dispatchers. I/O is used for I/O tasks, dispatchers. Default for CPU-intensive work, and dispatchers. Main for UI updates. Choosing the right dispatcher ensures your tasks run efficiently and your app remains responsive. Using withContext with the right dispatcher prevents blocking the main thread, which is crucial for smooth application performance. You can shift heavy or long-running tasks to background threads, ensuring that your UI remains responsive and your app can handle multiple operations at once. withContext helps you clearly separate concerns in your code. By assigning specific contexts for different tasks, such as UI updates or I/O operations, your code becomes more readable and maintainable. This structure also reduces the risk of threading bugs and makes your intent clear to other developers. By matching task types to optimize thread pools, withContext maximizes CPU and thread utilization. For example, CPU-intensive tasks can use dispatchers, default, while I/O tasks use dispatchers, I/O. This approach prevents overloading any single thread and ensures your application runs smoothly even under heavy workloads. withContext helps you avoid accessing shared resources directly from the main thread. By switching to a background context for tasks like database access or network calls, you reduce the risk of race conditions and ensure thread safety. This is especially important in multi-threaded applications. withContext ensures that the coroutine's context remains linked to its parent, supporting structured concurrency. This means that if the parent coroutine is canceled, all child coroutines, including those using withContext, are also canceled. This structure makes error handling and resource management much easier. One of the main benefits of withContext is that it simplifies threading logic compared to manual thread management. You don't need to write complex code to switch threads or handle synchronization. withContext handles all the details for you, letting you focus on your business logic. It's important to understand the differences between withContext, launch, and async. withContext suspends the current coroutine and executes sequentially in the new context, returning the result directly. Launch starts a new coroutine for background tasks that don't need a result, while async launches a coroutine and returns a deferred, allowing you to retrieve the result later with a wait. Use withContext for sequential tasks where you need the result immediately, such as switching to an I/O or computation context. It's ideal for cases where you want to perform a task and then continue with the result, all within the same coroutine. The launch builder is best for background tasks that don't need to return a result, such as logging or sending notifications. It creates a new coroutine and returns a job, which you can use to track its completion or cancel it if needed. Use async when you need to run tasks in parallel and retrieve their results later. Async returns a deferred, which you can await to get the result. This is useful for aggregating data from multiple sources or performing several computations at once. withContext propagates exceptions to the parent coroutine, ensuring proper error handling and maintaining structured concurrency. If an exception occurs within the block, it's thrown to the parent, allowing you to handle errors at the appropriate level in your application. You can use try-catch blocks within withContext to handle exceptions locally. This allows you to manage errors specific to the task, such as showing an error message to the user if a network request fails. It's a flexible way to ensure your app handles failures gracefully. Depending on the dispatcher or task context, you might want to handle exceptions differently. For example, you might log errors for background tasks or show alerts for UI-related failures. withContext gives you the flexibility to tailor your error handling to each situation. Let's look at a real-world use case. Suppose you need to fetch user data from a server. You can use withContext, dispatchers, I/O to perform the network call inside a try-catch block. If the call succeeds, you process the data. If it fails, you catch the exception and show an error message. This pattern keeps your code clean and robust. Another example is processing a payment. You might validate payment details, process the transaction, and send confirmation, each in a different context using withContext. If any step fails, the exception is propagated to the parent coroutine, where you can handle it globally. This approach ensures that your payment workflow is both reliable and maintainable. In testing scenarios, you might simulate network delays using delay inside withContext. This helps you ensure your app handles slow network conditions gracefully, and you can test your exception handling by throwing simulated errors. It's a practical way to build robust applications. For workflows involving multiple steps, you can use a parent coroutine to handle errors globally. If any step inside withContext fails, the exception is caught at the parent level, allowing you to show a global error message or perform cleanup. This pattern keeps your code organized and resilient. When using withContext, always choose the appropriate dispatcher for your task, handle exceptions at the right level, and keep your code modular. Avoid blocking the main thread and use structured concurrency to manage your coroutines. Following these best practices will help you write efficient, maintainable Kotlin code. A common mistake is forgetting to switch contexts for heavy tasks, which can lead to UI freezes. Another is not handling exceptions properly, resulting in crashes or unresponsive apps. Always use withContext thoughtfully and test your code under different scenarios to catch potential issues early. To recap, withContext is a powerful tool for context switching in Kotlin coroutines. It allows you to run code in different contexts efficiently, handle results and exceptions gracefully, and keep your codebase clean and maintainable. Mastering withContext will make you a more effective Kotlin developer. If you want to go deeper, explore the official Kotlin documentation on coroutines and try out different coroutine builders like Launch and Async. Experiment with different dispatchers and see how they affect your app's performance. The more you practice, the more comfortable you'll become with coroutine context management. Sometimes, a visual representation helps solidify understanding. Imagine your coroutine as a train switching tracks. withContext temporarily moves the train to a different track for a specific task, then brings it back to the main track once done. This analogy can help you remember how context switching works in practice. Let's quickly recap the core sample. Val result equals withContext, dispatchers, I/O, task. This simple line encapsulates the power of withContext, switching context, suspending the coroutine, and returning the result. Practice this pattern in your own projects to see the benefits firsthand. Kotlin coroutines offer many advanced features beyond withContext, such as channels, flows, and structured concurrency patterns. As you become more comfortable with withContext, try exploring these features to build even more powerful and responsive applications. Congratulations on reaching the end of this withContext deep dive. You now understand how to use withContext for efficient context switching, error handling, and performance optimization in Kotlin coroutines. Keep practicing, explore more coroutine features, and apply these concepts to your own projects for robust, modern Kotlin applications.